Okay, guys, so probability, hopefully you're already enjoying it and like, oh my gosh, this actually makes sense. So now we're going to talk about the types of distributions. There are 4 types of distributions in IB Math. We are only going to do 3. I know you're happy now. So the first one we're going to do is the probability distribution. Probability. Big words here for Mrs. Dean. Distribution. Okay, that's the first one. It's my favorite, not going to lie. It is Venn diagrams, which is what we're going to do today. Love Venn diagrams and tree diagrams. I love both of these. They are so easy. They're a lot of fun. I have seen some of the kids use these in their IA. I love it. I love it when we get to do them. Okay, the other one, which a lot of you will actually probably really like because it's really easy, is the binomial distribution. And those of your friends in AP Stats will be getting to this soon, and you will already know it, so you can help them with it. Okay, binomial distribution. This is why you guys will like it. It's all on the calculator. Okay, it's calculator driven. And we are going to learn 2. We are going to learn 1. It's called I have to make sure I write this right. Binom PDF, and we'll get into what all this stands for later. And binom CDF. Okay. And the last thing, or the third one that we're going to do is the normal distribution. And we've kind of already talked about a normal distribution. We drew our normal distribution, our bell curve. I'm just going to say bell curve. That everybody seems to know that. This is also calculator driven. And there's going to be 2 that we talk about. One's the normal CDF, and it's going to be norm CDF. And then we're going to do what's called an inverse norm. Inverse norm. And again, these are going to all be on your calculator. I'm going to see, I don't even know if I remember where all of them are. It's been so long since I've done it. So, let me go here. On your calculator, see that distribution right there, second distribution? You got the normal PDF, the normal CDF, and you got the inverse. And then our binomial one, I'm trying to remember where we got to that one. There it is down there. Yep. I'll remember it better whenever we get to it, but I love doing the probability distribution. It's so much fun. Now you're like, well, what's the other one? The 4th one is called Poisson's distribution, and that one is, if we were to teach my course at the HL level, we would do Poisson's distribution. It's just another distribution, just like these on the calculator driven and all that kind of stuff. All right. So let's take a look at some tree diagrams, tree and Venn. These are the ones, I just love these. Okay, so a Lego storage box has 7 bricks left in it and 4 blue ones. So we've got 7 red and 4 blue. Max takes a brick from the box at random and attaches it to his new castle. He then chooses another brick from the box. Create a tree diagram. Okay, well that's not too bad. When you create tree diagrams, there is stages. So this would be stage 1, and this would be stage 2. If we had another stage, we would put it here. Each of these branches would have a branch off of it. We'd have stage 3. I mean, we can make it really huge. Most of the time, we focus on a 1 and 2 stage. So we're going to call this stage 1. So what happens in stage 1 is that Max takes a brick from the box at random. Now, we know that Max could either take a red brick, right? He could pull a red brick. How many red bricks were there? There were 7, right? Let me go down here. There were 7 red bricks. How many bricks are there total? 7 plus 4 means I have a total in my bag. And I know one year when I did this, I just drew little things. And I put 7 red. 1, 2, 3, 4, 5, 6, 7. And then I've got 4 blue ones. So blue, 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 blue. I guess I could have moved them down some. Okay, so 7 out of my 11 bricks are red. Well, my other option is that I have blue bricks. And I have 4 out of the 11 are blue. So stage 1 says, I'm going to reach into my bag, and I'm going to pull out a brick. If I pulled out a red brick, then I would only have 6 left, right? So when I get to stage 2, I have the same options. I have a blue brick, or I have a red brick. Now that I've already taken a brick out of the bag, I don't have 11 bricks anymore. How many do I have? Now I only have 10. And the 10 that I have left, how many are red? Well, stage 1 says I picked a red one out. So now I only have 6 red left out of the 10 bricks. But I still have all 4 of my blue ones, but I only have 10 bricks left. Okay, that was if we stayed up here. Now let's go down here. Now we're going down here. So we're going to have blue and red. Stage 1, here we drew out a red one. Now this one says, what if we draw out a blue one? Well, I'm back down now here on the blue line. Instead of having 11 bricks, I only have 10, but one of them that came out was blue. So that means I only have 3 blue left. On the red, I didn't draw any red out, but I did take out a brick, so I only have 10 left. So 7 of those are red of the 10. So to me, Venn diagrams are just like, oh my gosh, that makes so much sense. I understand what we did. Okay, so we created a tree diagram. The next thing it wants us to do is calculate the probability that the 2 bricks selected are the same color. That means I could do red, red, or I could do blue, blue. This is where I use highlighters. On my tree diagram, I'm doing the probability that I get red, red, or I get blue, blue. So I'm going up or down this tree diagram on either highlighted route. I can do either one. So I want to do the probability that I get red or red. And since I'm doing blue and blue, when you have probabilities, remember you have to add them together. The probability of red, red, or blue, blue. Well, what's the probability of red, red? Let's see. I just want to rewrite this. As I look at this, well, let's just do the math, and then I'll come back and I'll do the vocabulary, because I want to write it as a probability. So the probability of red, the first time when I draw stage 1, there's 7 out of 11, right? Chances that it could be red. So I would say 7 out of 11. Now, as I go up the tree diagram, 7 out of 11 chances here, and 6 out of 10 here. It's important to note that when you go up a tree branch, you multiply up. So as I'm going up 7 out of 11, I would say times 6 out of 10. This is the probability of red, red. Now, a whole different probability is blue, blue. So I want to say plus. This is the probability of red, blue, blue. We're going to multiply up the ladder here, up the tree diagram. 4 out of 11 times 3 out of 10. There's my probability, red, red, plus the probability of blue, blue. Okay, so I'm going to grab my calculator because that's a whole lot of math there. Alpha y equals, I'm going to do, let's say 7 out of 11 times alpha y equals 6 out of 10. I'm going to go ahead and just put that there. So that's 21 out of 55 plus. Can I just go ahead and multiply this and get 12 out of 110? Y'all okay if I just do that? Okay. Now I need to put these together. So I'm going to do that. Oh. Was it second answer? Yep. Plus alpha y equals 12 over 110. So this adds to give me 27 out of 55 chances. 27 out of 55 that he gets red, red, or blue, blue. So here's my probability. But this is just kind of a number. I mean, I didn't really write it as a probability. So let's go up here. Let's write this, but let's write it in math terms. I know you're super excited about it. Probability. Remember, probability is P. Now we're doing the probability of red, and. When I'm using the word and, that's the intersection. That's the one that goes upside down. I want the probability of red and blue, right? Or red, or what do I want to say? I'm trying to think how I could write that. I think I would have rather written, I wrote it a little different, but let's do the probability of red and then red again. And then let's do the probability of blue and blue again. And then could we add those together? So here we go. We already know this. Red, we said it was 21 out of 55. And then we said the probability of blue was 12 out of 110. Then I could add those together, and we got 27 out of 55. This is a little bit more mathematical than what I said. I can see red, blue. I can see that. Now, some things to note about this particular problem. When I took the brick out at stage 1, did I put it back in? No, I didn't. So something I really just want you guys to remember, I'm just going to say important, is that when you are doing a probability, it can be with a deck of cards, it can be with, these bricks right here, you're going to want to always make note, is your probability with or without replacement? And I think I've mentioned that before, but it's super important that we keep that in mind. I'm going to even highlight that because I think that on this particular problem, it's probably the most important part of it is that you're not replacing the bricks on this problem. You are just solving this problem without replacement. And then I want to give you guys just some things to note. Now, I didn't leave myself much room right here because I got all writing real big. So I'm going to actually go back up here where I have a lot of room. So I'm going to put some notes here. I want to give you some pointers about the Venn diagrams. The branches, I didn't point that out. The branches of our tree diagram, they add up to 1. Okay, so 7 over 11 plus 4 over 11, what is that? Oh, that's 11 over 11, that's 1. 6 over 10 plus 4 over 10. Oh, that's 10 over 10. 7 over 10 and 3 over 10. Oh, they add up to 1. So, the branches of the tree, add up to 1. Right? So, as an example, 7 over 11 plus 4 over 11 equals 11 over 11, which is 1. Okay? The second thing I want to say is that the outcomes. This is the outcome. You multiply up the branch. Okay? Multiply up the branch. So I'm going to say that you multiply. Oh, sorry about that. I was looking to see, couldn't really see. Multiply up the branch. And I do want to highlight that word multiply. You multiply up the branch. And then the last thing I want to say, multiple outcomes. So in this scenario, you had red and blue. When you have multiple outcomes, you're going to add the probabilities up. So we're going to say multiple outcomes are going to add probabilities up. Okay, multiple outcomes. We are going to add probabilities up. And that is a tree diagram. Okay, I can't wait to do the next one. All right, so let me put that over here. Okay, so here's example 12. So the probabilities that Amanda successfully passes her math exam depends on the exam topic. The probability that the topic is statistics is 0.35. The probability she passes this topic is 0.3. The probability that Amanda passes any other topic during the exam is 0.8. Complete the tree diagram. All right, so I've got this tree diagram down here. We need to fill it out. So let's go back up here. Let's kind of look at some stuff. Statistics is 0.35. The exam other topic is 0.8. And we had 0.3 that she passes any of the topics. So if it happened to be a statistics topic, we're going to say that it was 0.35 if it was statistics. Okay. Then it said she passes this topic is 0.3. So here's our 0.3. So she goes up there. Then the probability that Amanda passes any other topic during the exam, any other topic, is 0.8. So that was here, right? Let's make sure we did it right. The probability that the topic is statistics is 0.35. So if this is 0.35 and I know that the tree branches add up to 1, let's do 1 minus 3.5 in our calculator, and we're going to get 0.65 here. Now, the probability that Amanda passes any other topic, so the probability that she passes after she got any other topic is 0.8. Can you figure out these other two? Well, yeah. The branch adds up to 1. So if I just look at the top, if this is 0.3, that means this would be 0.7. And if this is 0.8, that would mean this would be 0.2. Already you're probably like, oh my gosh, I love tree diagrams. They're so easy. Yes, they are. They just make sense in my book. All right, now we created the tree diagram. Now it says find the probability that Amanda does not pass. So this is does not pass and this is does not pass. There are two different avenues that she could get there. So we're going to grab our highlighter and we're going to highlight the paths. She could draw statistics or get statistics, and then from here she could not pass. Or she could get any other topic, and then from here she could get does not pass, right? Two different avenues. So I need to take two separate probabilities. I need to do the probability that she gets statistics, right? Probability that she gets statistics, but she doesn't pass. So how do I want to say that? And she doesn't pass, or she doesn't pass. I guess it would be more of a and she doesn't pass, right? So I actually wrote it wrong. I want to write it like this. I want to use some different terminology. I want to say this. I want to say the probability that she doesn't pass, because remember that's what they said, find the probability that she doesn't pass. I want to find the probability, so I'll use P for pass, and then I'm going to use the not. She does not pass given what? What's she given? It's like I'm working backwards. Given that she got statistics, that she got a stats test. Okay? And then I want to do the other avenue down here, the probability that, again, she doesn't pass. So I'm going to say not pass given any other topic, that she got any. I'm just going to say any math. Any topic. I guess I should say topic, because we don't know that it was math. Okay, so two separate probabilities. What am I going to have to do with these separate probabilities when I find the value? I have to add them together. Okay, so remember we multiply up the chain, right? So the probability that she doesn't pass given that she got statistics is going to be 0.35 times 0.7. I've worked it already and I got 0.245. 5. Okay, now let's do this. The probability that she doesn't pass given that she got any topic. So I'm going to say 0.65 times 0.2. And I already multiplied that as well, and I got 0.13. Now I need to put all this together. When I put these two together, what am I saying? The probability that she does what? I'm basically saying the probability that sweet Amanda fails the test, right? The probability, because they both lead to that she doesn't pass. So I'm just going to come down here and say that probability that she does not pass. That's what I'm doing here. 2 avenues to get there, but the end result, she's not passing. I'm going to take 0.245 and add it to 0.13. And I got 0.375. Well, you know what? When you think about it, that's actually a higher... What's the probability that she would pass? What's the probability that she would pass? Well, remember probabilities, what do they add up to? They add up to 1. So could we say 1 minus 0.375 equals, here we go, 1 minus 0.375, 0.625. So that's the probability that she passes. I like those. That's better. It's better. Okay, so here we go. Check for understanding number 3. I'm going to go ahead and, I think I'm going to just keep this on this video. Where's our video at? Oh, no, we're at 22 minutes. I'm going to stop it and I'll do check for understanding separate.